This is Chemistry, Unit 14, Acids and Bases. Here we'll look at the concept of pH. Determining if a solution is acidic, basic, or neutral is not easy if one uses concentrations. In 1909, Soren Sorensen, who's in this image right here, proposed the pH scale to express H3O+. I believe he was actually working for a beverage company, like quality control, and he came up with this system to make it a little bit easier for himself when determining the quality of the beverage, because you don't want it too acidic or too basic, right? You're going to be digesting it, so he came up with this concept, which is awesome. So the pH of a solution is the negative logarithm of the hydronium ion concentration. So those are some big words, right? But it actually means this equation right here. So pH equals the negative log of the hydronium ion concentration. So let's take a look at the pH scale. So the scale ranges from, let me actually color code this, 0 to 14. And I'm using these colors for a reason. And then right in the middle, you have 7. So 7 is considered neutral. Anything below 7 is considered an acid. And I use the red because acids turn pH paper red. And anything above pH 7 is considered a base. Okay, and bases will turn pH paper blue. So over here you have the numbers 1, 2, 3, 4, 5, 6, and then 7. And then over here you have 8, 9, 10, 11, 12, 13. So obviously I'm not drawing this to scale, but those are your numbers, right? But what I want to point out to you is the difference between these numbers. So it isn't just a difference of 1 to 2 to 3. It's not a difference of 1 in between each of these numbers. It's actually a lot greater than that. So between pH 1 and pH 2, there is a difference of 10. That's what logarithm is based on, right? The number 10. So in between pH 2 to pH 3, it's not a difference of 1, it's a difference of 10. So if you look at my question here, I ask you how much stronger is pH 1 compared to pH 3. So first of all, the farther down the scale you get, the stronger the acid, because you're getting farther and farther away from being neutral. So over here at this 0 to 1 end, this is a really, really strong acid, like car battery acid, for example, sulfuric acid. Same thing with the basic scale, right? The farther and farther away you get from 7, you have your stronger and stronger bases. So over here towards the 13, 14 end, you're looking at something like Drano, right, which is to clean pipes. But in any case, what's the difference now, right? So from pH 1 to pH 3, so remember that, from pH 1, you're going to pH 2, and then to pH 3. So this is not a difference of 2 because it's 2 steps. It's actually a difference of 10 times 10, which is 100. So pH 1 is 100 times stronger than pH 3. Makes sense? So it's not a difference of 1 in between here. It's actually a difference of 10. So let's just take a look at some examples of what might be on the pH scale in terms of each of the numbers. So here is the concentration, right? And then here is the pH. So the pH is a lot easier to deal with than these numbers. So that's where the scale is coming from. So at pH 0, yeah, you're looking at battery acid, which is the most acidic. So you're looking at like H2SO4, which is in car batteries. pH 1 will be HCl, your stomach acid. pH 2, lemon juice. pH 3, orange juice. pH 4, acid rain. pH 5, black coffee, Yes, coffee is acidic, so a lot of people don't like the taste. pH 6 would be your saliva inside your mouth. And then if we head over to neutral, you're looking at distilled water, which should make sense, right? And just think of how much you consume. A lot of these things like saliva, you always have in your mouth, and think about it. People drink coffee on a daily basis, right? But you can only take so much orange juice, right? And then lemon juice, you don't really drink lemon juice on its own. You use it in a recipe. So that should make sense. Then HCl is your stomach acid, and that's pretty strong. If you've ever thrown up, you can feel that burning in your throat. But the stomach is an amazing organ because it's got that lining, which stops the HCl from hitting any of your other organs. All right, now let's move towards the basic area. So pH 8 would be something like salt water, like the ocean. pH 9 would be baking soda, which you'd use in recipes. Don't necessarily eat that on its own, but in recipes, quite good. 10 is milk of magnesia, or like your Tums, right? A lot of your antacids. And why are they antacids, right? They're trying to soothe that stomach acid. So acids plus bases make salt and water. We did learn that, so that's why you take the milk of magnesia or Tums, Pepto-Bismol. 11 will be an ammonia solution, which is a pretty strong cleaner for floors, for example. 12 would be stronger soapy water. 13 would be like an oven cleaner, which would have an even stronger smell. And then 14 would be something like Drano, which, you just drop it in the pipes and hope it works. Doesn't necessarily work all the time. You usually have to add more. It depends on the type of clog you have as well.